Hello, it is good to see you again. Welcome to Block 5, Fraction, Decimal, and Percentage Equivalence, Lesson 11. I'll share my screen. So, in your previous lesson, you learned how to represent any fraction as a diagram. In today's lesson, you're going to learn how to represent fractions on number lines. This is a very important skill that has a lot of practical applications. So it will prepare you, yes, for your secondary school maths exam, but it will also prepare you in knowing how to read charts, knowing how to read scales. So it's a very, very important skill. But before we start, I would like you to share the video and like the video, subscribe to the channel, spread the word so that you can do us a huge favor and children around the world in making our program a success, which is to educate the global population of children, even if they cannot afford a private tutor or maths teacher. Thank you. Before we start, I would like you to do these retrieval practice questions. You can pause the video and answer these retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So here you were asked to complete the number line. Now, if you recall in our previous lessons, the way we work out interval is first we count these as intervals. So these are intervals. So that's 1, 2, 3, 4, 5, 6, 7, 8. So the spaces in between are what we count as intervals. Then to work out how to fill this number line is we find the difference between the start of the number line and the end of the number line. In this case, the difference is 40 minus 0, which is 40. And then we divide that number by the number of intervals. So in this case, we have 8 intervals. So if we do 40 divided by 8, our answer will be 5. So it means each interval is worth 5. And that's how we complete our number line. So we write 5, 10, 15, so it goes up in 5. Okay? All right. The next one, you were asked to fill in this missing value here to be able to get 1. So 9/9 is equal to 1. So 9 divided by 9 is equal to 1. So let's rub that off so that we'll get ready for the next part of our lesson. Okay, next, you were asked to use the greater than or less than symbol to complete the statements. This one is easy to compare. We can see that we have the same denominator, okay, equivalent denominator, so which is 7. So simply comparing the numerators, we can see that this is greater than that. So 6 sevenths is greater than 5 sevenths. Let me return to my cursor. Let's remove that. Okay. And then next one, we have 5 tenths. How do we know that is greater than 48 hundredths? Well, if you remember our lessons on 100 squares, you will know that 5 tenths means 50 hundredths. So you're going to have 5 columns of 10. That's what 5 tenths mean, 5 columns of 10, and that makes 50. So that one is 50 hundredths, so it's greater than 48 hundredths. Let's do some new learning. as we focus on today's lesson, which is to be able to represent any fraction on a number line. If we're asked to label each interval on the number line, the first thing we need to do is to use the skill that we used in our first question, which is this one, in our retrieval practice. So we know that the difference is 1. So 1 minus 0 is 1. And then we count the intervals. We can see that we have 1, 2, 3, 4, 5, 6. We have 6 intervals. Now, it means we have split this line into 6. So if we do 1 divided by 6, okay, so we have 6 intervals. So if we do 1 divided by 6, that is 1 6. Okay, so that's how we write 1 divided by 6. So 1 6. And then we can now start completing the number line with the fractions. So the first one will be 1 6. The next one will be 2 6, 3 6, 4 6, 5 6, and 6 6. 6 divided by 6, which is 1. Let's look at another example. How would we show fifths on this number line? Have a think. How would we show fifths on this number line? Well, you may be thinking that this would be right. Say, okay, because we want to show fifths, we just need to draw 5 equal bars on the number line. Is that correct? Well, I don't think so, because if you recall, our skill is to know how to split the number line into equal intervals. So if we're looking for fifths, if we want to show fifths on the number line, we're going to have 5 intervals. But if you look carefully, you will see that we have 6 intervals. So we won't be able to show fifths here because we have 1, 2, 3, 4, 5, 6. So we need 5 intervals to show fifths. So we're going to have to make some changes. All right. And that has to be 4 intervals like that. Okay, now you can see that we have 1, 2, 3, 4, 5. So we can now show fifths. So 1 fifth, 2 fifths, 3 fifths, 4 fifths, and 5 fifths, which is also equal to 1. All right, so we have done some learning. You now know that to be able to show fraction on a number line, you should know the number of intervals. You should know the difference between the start and the end of the number line, and then divide that number by the number of intervals to know what each interval, what value you would give each interval. Pause the video and answer question 1 in 2 minutes. You can take longer. You can work at your own pace. You don't have to do it in 2 minutes. So work at your own pace. The most important thing is you enjoy learning and you understand the maths really well. Assuming you've paused the video and you've answered the questions, here are the answers for A, B, and C. Okay, so you can see this has to be 3 tens because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 intervals. So that will be 1 tenth, 2 tenths, 3 tenths. This one we have 8 intervals. So that has to be 3 eighths. Yeah, that will be 1 8, 2 eighths. Then this one we have 1, 2, 3, 4, 5. We have 5 intervals. So that has to be 3 fifths. Yeah, that's 1 fifth, 2 fifths, and 3 fifths. All right, mark your work, celebrate your success. Well done. Pause the video and answer questions 2 and 3 in 3 minutes. You can take longer, work at your own pace, okay? All right, assuming you've paused the video and you've really worked hard, you've worked through the questions, here are the answers. Let's discuss them. For question 2, you were asked, Aisha says that the arrow is pointing to 1/3. Aisha is not correct. Why do you think? She might have thought that. Discuss that with your partner. So if learning this with somebody, or with you're seated with an auntie, an uncle, a friend, you can discuss it with them. All right. So we can see here that we have 1, 2, 3, 4. Okay. We have 4 intervals. Now, if we divide 1 by 4, because the value from the beginning to the start of the line is 1, 1 minus 0 is 1, and we have 4 intervals. So if we divide 1 by 4, we would have a quarter. So it is 1/4, not 1/3. And then here we'll ask to draw an arrow from each fraction to its correct position on the number line. So by now, you should be able to know how to position intervals. All right. Pause the video and answer question 4 in 1 minute. You should be able to do this in 1 minute. Or you can take your own time to do it. So don't worry about it. Take your own time. Okay, assuming you've paused the video and you've worked through the questions, here are the answers. Let's discuss them. Here is a number line from 0 to 1. Okay, 0 to 1. You've been asked, so remember the question says label the point X at 2/5. So they want you, okay, to use a number line from 0 to 1, and you need to label the correct point where you would find 2/5. And then you need to explain how you decided where X would be. Of course, you would need to split the number line into 5 intervals because you want to show fifths. All right. And you need 4 bars to do that. 4 bars that splits the line into 5 equal parts. Now, that's the explanation here. So 2/5 will be there. So well done for the first part of the lesson and for working really hard. We now need to do some further learning building on what you already know. So well done. What about this one? If we have to label each interval on the number line, how do we do this? Well, it's the same approach. It's the same approach. We would say, well, we have 0 to 2. Yeah, the value between 2 and 0 is 2. So 2 minus 0 is 2. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 intervals. Now, there are different ways we can do this. So I'm going to show you 3 different ways of thinking about this problem. So the first one, we have 2 8s. So we can simply say, okay, what does 2 8 simplify to? So we know we can write 2 divided by 8 like this. Now we know 2 and 8 are in the 2 times table. So we should be able to divide 2 by 2, and we should be able to divide 8 by 2. If we do that, we're going to have a quarter. So it means each of these interval is actually a quarter. So we'll have 1/4, 2/4, 3/4, 4/4, 4/4, which is 1, 5/4, 6/4, 7/4, and 8/4, which is 2. Yeah, 8 divided by 4 is 2. Yeah, so that is one way of doing it. But let's look at other ways of answering the same question. Okay, let's rub this off. Okay. All right. So another way to think about this is to use our bar model. We can say, okay, we want to divide 2 bars into 8 equal parts, which means that each bar has to be divided into 4 equal parts. So we'll get that. Now, if each bar is divided into 4 equal parts, if you think about it, remembering how we represented any fraction as a diagram, this will have to be a quarter, so 1/4. So that is one way of thinking about it. Okay, another way of thinking about it is to say, okay, what is halfway between 0 and 2? It has to be 1. right? Now, if we look at just this first half of the number line, we can see that we have 0 to 1, 0 to 1 as the value from the beginning to this part of the number line. But we have 4 intervals. So it means if we do 1 divided by 4, it will have to be a quarter. So in any of these 3 methods, we'll quickly see that we have 1/4, 2/4, 3/4, 7/4, and 8/4. Okay, let's look at our last example. Now, I really want you to pay close attention. So imagine that you're given these number lines, but it's put on a square centimeter grid. All right. And then you're asked if each number line goes from 0 to 1, which number line would you use to label 8s? Have a think. Interesting question, isn't it? But if you've been following what we've been learning, you would see that it is not really a difficult problem. Because if we have to label 8s, it means that we need to have a number line that has these square grids, okay, having 8 square grids or a multiple of 8 square grids. So listen, let me repeat that. It means we need the number line that has 8 square grids, yeah, 8 of these little squares, because that's how we can, these little squares represent our intervals, right? Or we'll have a multiple of that. So multiple could be, okay, it could have 4 square grids. Okay, it could have 4 squares. Yeah, or it could have 16 squares. Or it could have 32 squares, right? Or 24, right? So let's now use this idea to think about the solution to this problem. Will that work? Obviously not. It obviously will not work because, yes, we can represent 8s, but we won't have equal intervals. This one? Of course not. This one? Of course, yes, because look, we have 8 intervals looking at the squares. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we can actually represent 8s on this number line. This one? Of course not. We can't use that one. This one? Yes. Why? You can see that we can actually represent 8s. Why? If we choose to make 2 bars equal to 1, yeah, if we choose to do this, then we can represent 8s. Guess what? Yeah, look. So we have that one. My pen is moving. Come on. All right. We have that one, that one, that one. Okay. So you see, we now have, although there's 16 squares, but 16 is a multiple of 8. Multiple means 16 is in the 8 times table. Okay. 8 times 2 is 16. So you can see 2 of the squares make one interval. So 1, 2, 3, 4, 5, 6, 7, 8. Right? What about this one? Again, we can see that, yes, we only have 4 bars, but we can also represent 8s. If we make each of these 2, so let's say this is 2, this is 4, all right? So if we make each of them 2, that's 6, and that's 8. So it means halfway can be 1/8, okay? So halfway can be 1/8. All right, let's move on. Okay, all right. So far, we know we can represent this. We can use that to represent 8 because we can make each of these, if each of these is 2, then we can use it to represent 8. Okay. What about this? This one has, this another example, I think this is the last one. We have a number line that has two different scales. So you have a scale on top and you have a scale at the bottom. This is typical of scales we would see in real life, where you have two different scales. Maybe your measuring jug, maybe you see like those, you see maybe the scale that your uncle uses as a technician. You see different scales on top, one on top and the other at the bottom. You should be able to know how to read these. So we have at the bottom, we have 1, 2, 3, 4, 5, 6. So we have 6 intervals. So between 0 and 1, we know if we have 6 intervals, we're going to be representing 6. So that one will be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and then 6, 6, which is 1. But on top, we have 3 intervals. So we have 1, 2, and 3. Now, but we still have between 0 and 1. So it means we can represent thirds on top of the number line. Yeah, on top of the number line. So we can have 1/3, 2/3, and then 1. Now, notice something. 1/3 is on the same part as 2/6. So they are called equivalent fraction. If we simplify 2/3, so if we divide 2 by 2, we'll get 1. And if we divide 6 by 2, we'll get 3. So they are equivalent. And same is 2/3 and 4/6. Now, with this number line, you can even start to tell which of the fraction is greater or lesser than the other. So we can say, for example, that 2/3 is less than 5/6. Why? Because comparing the fractions, you can see that 4/6 is equivalent to 2/3. They have the same denominator. You can simply just look at the numerator and see that 5/6 is greater than 4/6, which actually is 2/3. It's now time for you to practice what you've learned. So what we've learned so far is you should be able to look to find out different values on the number line, even if the number line does not end in 1. So maybe you start at 0 and you end in 2. We use the same skill that we used from the very start of the lesson when we did our retrieval practice working with integers, that is whole number. Pause the video and answer question 5 in 1 minute. You should be able to do this in 1 minute. Assuming you've paused the video and you've answered question 5, here are the answers. So here you ask that the coffee shop is half kilometer from Scott's house. Scott's school is 1 kilometer from his house. The coffee shop is half kilometer from Scott's house. The factory is 2/7 kilometer from Scott's house. You ask to indicate on the number line where the coffee shop and factory are. So you can see with that we're dealing with 7th. So it means we're going to need 7 intervals. So 1, 2, 3, 4, 5, 6, 7. Not quite. Okay. So Scott School is 1 kilometer. So we have 0 to 1. The coffee shop is half kilometer, so we'll find half of the number line, halfway of the number line. Then the factory is 2/7 kilometer from Scott's house. So 2/7 from Scott's house would be, so we're going to need so that's 1, 2, 3, 4, 4, 5, 6, 7. So 7 intervals. So I got confused with the halfway point. So that's seventh. So it means 2 sevenths will be the second interval. Okay. All right. Next one. Question 6. Pause the video and answer question 6 in 1 minute. Assuming you've paused the video and you've answered the question, here are the answers. So here you were asked, are these arrows pointing to the same fraction? Well, you're going to have to fill in the number line to find out what fraction represents this position to know whether they're the same. All right. So no. Why? The number lines are split into the same number of intervals, and the arrow is pointing to the same point, but the end points are different. Okay, so you can see that the end points are different. So if we were to write the fractions on the number line, this number would be different because this is 1, 0 to 1. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will show 12ths. So this will be, the start will be 1, 12, 2, 12, 3, 12, 4, 12, 5, 12, 6, 12, 7, 12. But this is 2, right? So between 2 and 0, we also have equal number of intervals, which is 12. So if we divide 2 by 12, it means the first one will be 2, 12, 3, 12, 2, 12. So going up in 2. So each of the interval will go up in 2s because we've divided, each interval will be worth 2 over 12. Or we can simplify it to be 1, 6. So that will be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. All right. And then 7, 6. So they do not represent the same fraction. Question 7, pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered the question, here are the answers. Question 7, you're asked, how far along the number line is the point marked? Now, each square represents the interval, right? So we have 0 to 1, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So each of the squares represent the interval. So we have 1, 2, 3, 4, 5, 6, 7. So it's 7 18ths, 7 over 18. And then you ask, mark the point 8 over 9 of the way along the number line. It has to be there, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 intervals. Now, along here, we have 16 over 18. Yeah, so this is our 16 over 18 position. So if we simplify 16 over 18, you would see that that simplifies to 8 over 9. So let's write this. So this is 16. This point here is 16 over 18. Now, these two numbers are in our 2 times table. So we can divide 16 by 2 to give us 8. And we can divide 18 by 2 to give us 9. So that is the position. So mark your work and celebrate your success. If you did not get it right, that's okay. You learn from your mistake and you get better at this. Okay? So let's remove that. All right. Pause the video and answer question 8 in 3 minutes. Assuming you've paused the video and you've answered question 8, here are the answers. Let's discuss them. Here you ask, the number line shows both fifths and tenths. So you ask, draw arrows to show 2/5 and 7/10. So by now you should know how we position numbers, fractions on the number line. So that should be 2/5, all right? And that should be 7/10. And then here you're asked to use the number line to complete this. So you have 2/5. That the denominator is 10, so it's been made 2 times bigger. So we need to make the numerator 2 times bigger. Here, we've made the numerator, we've made the denominator 2 times smaller. So we'll have to make that 2 times smaller. So that is to divide by 2. And then here, we can make the denominators equivalent. So if we multiply by 2, that will be 6/10, which is obviously greater than 3/10. And we can do the same here. If we multiply this by 2 so that the denominators can be the same, this will be 8/10, which obviously is smaller than 9/10. So 9/10 is greater than 8/10, which is 4/5. Pause the video and answer question 9 in 2 minutes. Assuming you've paused the video and you've answered question 9, here are the answers. Let's discuss them. So now you ask, how can you mark 8 on this number line? How can you mark 8 on this number line? Of course, remember, this takes us, explain your method to your partner. Now, remember, in halfway through our lesson, we said, if you're going to represent fifths on a number line, you need 5 intervals. If you're going to represent sevenths, you need 7 intervals. So if we want to represent 8s, it means we have to split this line into 8 equal intervals. And then check this out. So we have 1, 2, 3, 4, 5, 6, 7, 8. All right. So I'm sure you explained that correctly to your partner. And then you're told, use the number line, show that 3/8 is less than 7/12. Yeah. So 3/8 is right there. 7/12. One way to do that is to make the denominators equivalent. So we need to look for a number that we can multiply by 8 to get the same number that when we multiply that number by 12, we'll get the same number. We'll do the same to the numerators, and then we'll get the answer. Okay. All right. So that brings us to the end of our lesson. Just to make another note on this, another way to do it is to draw another number line underneath and then split that number into 12 equal parts. Now, when you show 7/12s, yeah, you would see that 7/12s will be further down, yeah, because we want to show that this is less than that. So you will see that if you draw another number line underneath here and you split that number line into 12 equal parts, and then you subsequently show 7/12, you will see that 7/12s will be further down about this region, somewhere this way, which obviously shows that it is greater than 3/8. Okay, that brings us to the end of our lesson. Well done for working hard. It could be a little bit challenging lesson, but if you need to watch the video again and to really understand this, please do, and practice more with the practice questions. So that brings us to the end of our lesson. So what we've learned so far is we have learned how to represent fractions on a number line by using our interval technique, knowing how to find out the value between the end and the start of the line, and to divide by the number of intervals. The same skill works when you're working with fractions, and it's a very important skill in knowing how to read scale, in knowing how to plot graphs, and it has practical application even in the kitchen. Okay, so when you're baking, when you pick up that jug, that measuring jug, you should know how to read intervals. Until next time, take care and bye-bye.